Alright folks, just going to look at how we can figure out the length of the major arc in the area of the minor sector, regardless of what the angle is here. I'll just make up something and say this is 50 degrees, and we're going to figure out the length of the major arc. Now the length of the major arc is this length here. Okay, this is the circumference that does not include the little small section there. Major means more than 50%. So then this, I'll do this one in green here for you. This is the minor arc in here, the circumference of that small green section. The major arc is the red section. That's what we're going to do. And we're just going to figure out, first of all, the circumference of the whole thing, given that the radius is 10. And so if the radius is 10, the circumference is 2 pi r. Okay, so in other words, circumference is 2 times pi times the radius, which is 10. Or in other words, the circumference is 20 pi. You can leave it in that form, 20 pi. They'll do the actual calculation, nothing wrong with that whatsoever. But that's the circumference for the whole thing. But I don't want the whole thing, I only want a portion of it. Okay, now you can do this a couple of ways. You can figure out how much of it here is missing and subtract that from the whole thing, or just figure out what ratio you actually want. In other words, if that interior angle is 50 degrees, this exterior angle is 310 degrees. Okay, so in other words, I want the portion that represents 310 degrees out of 360. Okay, and if I multiply that by my circumference, in other words 20 pi, that will get me to my answer. Now if you do a little bit of fraction math, you can work out this answer to be 155 over 9 times pi, which works out to be, in this example here, 54.1. Okay, and either one of those is acceptable. Either 155 over 9 times pi, or 155 pi over 9, or 54.1. And that's how we do the major arc. In the next video, I'll show you how to figure out the area of the minor sector.